Hello? Hello out there. Hello out there, I'm on the air. It's chemistry tonight. The electrons are charged, the protons are charged, and the atoms are in plain sight. The molecules bump and the electrons jump, and the burners are on flames. Atoms in the wall, atoms in the floor. Oh, atoms in the door, atoms in the floor. It's the good old chemistry game. Interesting. Now, is it working? I can see this. So it looks like there's stuff. Let's see if this works, I guess. The entries in the periodic table, which we're going to refer to as cells, are given by the atomic number or the number of protons. So the way that the elements are listed out, hydrogen being 1 has 1 proton, and conversely and respectively has 1 electron. Helium having 2, lithium 3, etc., and that's how they create the periodic table. Sodium is the 11th element on the table because it has 11 protons. The atomic mass is composed of the number of protons plus the number of neutrons. So what I mean by that is, here we have an example of a cell. The left-hand corner typically is you'll find the atomic number. That's just equal to the number of protons. So we're looking at the atomic number, it's just equal to the number of protons. In the middle, you'll have the name of the element plus its short form symbol, as well as finding the atomic mass. So the atomic mass is equal to the combined amount of protons and neutrons, or P plus N. We know that the number of protons is 11, and the total atomic mass is 23, and that the protons plus the neutrons is equal to 11. Well, that means that our protons 11 plus the number of neutrons that we have will have to equal 23. So therefore, subtracting 11 from each side, we're going to get 12. So if I use a pen that actually writes, n will equal 12. Excuse me. So n is equal to 12. So therefore we know there are 12 neutrons. So then when we go to draw it, we will have 11 protons and 12 neutrons inside the nucleus of our atom. So recall that atoms are made up of 3 things: electrons, protons, and neutrons. Electrons are small particles, almost zero mass, with a negative charge, found orbiting the nucleus in quantized energy levels. Protons are large particles of atom mass is composed of the mass of protons and neutrons with positive charge, found in the center of the atom known as the nucleus. The rings of the electrons that encircle the nucleus will follow a specific pattern. So this is the pattern that the electrons follow. In the first ring there are 2 electrons, second ring 8, third ring 8, fourth and fifth 18, and sixth and seventh have 32. This is important when we're starting to draw our board diagram. Neutrons are a larger particle, almost the same mass of protons, if sometimes they're it's around approximately the same, that have no charge, and they're also found in the nucleus. Atoms are just a combination of these three particles. So if we're looking at making an atom, we're going to look at making most of these atoms you can find from the cell. So look at the example for lithium. The atomic number is 3, so therefore it has 3 protons. The atomic mass has a mass of 7, which means that it's equal to the protons plus the neutrons. Since the protons is equal to 3, we will have 3 here. So therefore, that's going to mean that we're going to have, subtracting 3 from each side, 4 neutrons. When I go to start to build this, I'm going to put in 3 protons and 4 neutrons. Now, elements are always neutral. What that means is that the electronegativity will be neutral, so that there has no charge on it. Since protons have a positive charge, and electrons have a negative charge, we have to build the atom in such a way that it becomes neutral. Well, since we have 3 plus, we have to introduce 3 minus. So after we've done that, we have to think about this. Is this correct? Well, first ring we said can only have 2, so one of these electrons will be on the outer layer. And that's all it takes for building a Bohr model based off of its element cell. So let's give another example. So let's look at oxygen. So what are the number of protons? Well, I will get that from my atomic number. So we know that it's going to be 8. What's my number of neutrons? Well, I have to look at my atomic mass, which is 16, and look at my protons. So remember that the protons plus the neutrons will equal my atomic mass. So 8 what will give me 16? It again will be 8. So how many electrons am I going to need in order to keep this balanced or keep it neutral? If there are 8 positive charges, that means I'm going to need 8 negative charges. So I'm going to have 8 electrons. So building this, I needed 8 of these. There's my 8. And I need 8 neutrons. So now I've got my nucleus created. I need 8 electrons. So remember the electron configuration had 2 on the inside, then a maximum of 8 on the outer. But how many do we need total? We only need 8, so that means we'll have 6 on the outside. So just pulling those in. Four. Double this one up. Double this one up. Normally I start in a circular pattern, starting from the top and just moving my way around. So now we count again. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 electrons. Now we've created the Bohr model for oxygen. This process can continue for things like argon. Well, how many protons are in argon? We have 18. And again, there are 40 atomic mass, so that means the protons plus the neutrons will equal 40 to give me 22 neutrons. So, bringing in my protons, we'll make this a little faster. We'll say we've got 18 of those. And bringing in my neutrons, we said we had 22 of those. How many electrons will we need to keep argon level, or neutral, sorry? Well, we're going to need the same amount of protons, so we're going to need 18 electrons. So bringing in the 18 electrons, so if I have 2 on this layer and a maximum of 8 on my second layer, that will give me 2 plus 8 is 10. So I'm just going to do the fast way and put these around. Oops. 8 on this layer and 2 on my first layer. That gives me a total of 10. How many would I need to put on my outer layer, or my next layer? Again, we're going to need 8. So what I'm going to do is I'm just going to copy these, and copy these. Oh. Now remember, the first layer had 2, then 8, then 8. Since we have a full outer shell, we have what's known as a stable. It's its most stable position. And when it's its most stable, we end up having all the noble gases. And the noble gases are found in the far right column. And that's how we create atoms. So let's look at working backwards from that. So we're going to make the element cell based off of the Bohr diagram. Well, first of all, let's start with the number of protons, and that will give us our atomic number. In this case, we have 5. So we have 5 protons. How many neutrons do we have? Well, we have 3. 3 is 6. So total atomic mass will be 5 plus 6. So that will give us 11. Or you can, sometimes it's written here in the middle. Now, let's go to our periodic table and figure out which element has 5 protons. Well, 1, 2, 3, 4, 5. We're looking at boron. So boron, oops, oh wait. Boron has a big capital B. And boron. Terrible writing. Alright, if we look, we've got 1, 2, 3, 4, 5 electrons. That means it's neutral, so then we've got the right answer. So again, let's look at this example. We've got 3, 6, 9 protons. We've got 4, 8, 10 neutrons, so that gives us a total mass of 19. So let's go to our periodic table again and look for what has 9 protons. So looking for the 9, we have fluorine. That's fluorine. That's the hand signature for fluorine. And again, if we have 9 protons, we should have 9 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, it's balanced. Formation of an ion. So, scientists know that the most of the matter on Earth is found as compounds or molecules rather than single atoms. From this evidence, scientists have inferred that blah 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 blah. This is just a test, blah blah blah, valence electrons, blah 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 blah. So, when it has a full 8 or full outer ring, it's called an octet rule. Atoms that have gained or lost an electron, so remember we talked about if it always has to have the same number of protons and electrons. If it doesn't, then it's known as an ion. If an atom gains an electron, it has more electrons than protons and becomes a negative ion or an anion. If an atom loses an electron, it has fewer electrons than protons and becomes a positive ion or cation. Whether an atom gains or loses electrons in order to become a cation or anion depends on the number of electrons it possesses in its outer shell. The electrons in the atom's outermost shell are called the valence electrons. So the ones that are hanging on the outside group are called valence electrons. Ions. Ions, like I said, are simply just additional amounts of negative or extra electrons or positive loss of electron charges. Note, remember that elements are usually neutral, so the number of electrons equal the number of protons. So going back to the lithium example, we had 3 protons, this guy should be out here, 3 protons and 4 neutrons with 3 electrons. So I have a little scoreboard over here talking about the number of protons and number of electrons. Should we lose an electron, so we only have 2 electrons, we have an excess amount of positive charge. So we would write this as lithium, and we indicate it as a +1, because it has one extra positive charge. Now, is it an anion or a cation? So if you can't remember, anion is the one that has an extra electron, and a cation is one that loses an electron. So since we lost an electron, this will be a cation. So if we bring my electron back in, get rid of this, and it balances again, so we're at 3 apiece. If I were to introduce a couple extra electrons, we have 5 electrons. Well, now we have an excess charge, an excess negative charge. So that's going to mean that we have lithium. Oh, probably don't want to use the highlighter. We're going to end up with a lithium minus 2 charge because we have 2 extra electrons. And again, is it an anion or a cation? Well, it's an anion because we have 2 extra charges. You understand? So now it's your turn to show me what you think. So you're going to use the atom builder to practice using the practice by using the atom builder. When you're ready, you can play the following games. So you'll create board diagrams depending on the element, or it'll ask you which element it is based off the information, and then you're going to complete the cell based off of the information that's given, usually a board diagram. When you finish the game and your results is displayed, take a screenshot of the results and paste them into the Atoms worksheet document. Then you can submit this into the Dropbox, and we'll get that created for you. Well, thank you for watching, and have a good day.